So this is an interesting limit that we would like to compute. First of all, we start by plugging in x equals 1, and we get 4 on the top and 0 on the bottom, which means that right away we should try to do synthetic division on the bottom or factorize it in some other way. And it's not too hard to see that we obtain this x squared minus 2x plus 1 is equal to x minus 1 times x minus 1, which of course is the same thing as x minus 1 squared. Now, this is where you would normally have a situation where the limit doesn't exist, except that you have this exponent 2, which makes the quantity x minus 1 squared always positive. With the exception, of course, x being equal to 1, but again, since we're approaching 1, we don't want to plug in the number 1, especially since the denominator becomes 0. So what changes here is we could take the one-sided limits and we would get the same thing. And let's actually do it, and then I will show you what the alternative would have been. So if we take the limit as x tends to 1 from the right of x cubed plus 3 over x squared, let me write it in its factorized form, x minus 1 squared, then we would think of it as x tends to 1 from the right of 1 over x minus 1 squared. We have to factorize the whole thing because the whole thing is responsible for the 0 in the denominator. And then we would get that this tends to 4. Whereas for the other term, we get an x minus 1 squared, or rather, as x approaches 1 from the right, we get two things, that x minus 1 squared approaches 0, and x minus 1 squared is positive, which means that 1 over x minus 1 squared tends to positive infinity. So this component tends to positive infinity, and the whole thing has limit positive infinity. The interesting thing is that if we try to do this from the left, it's identically the same thing because of the square. So we would get the limit as x tends to 1 from the left of 1 over x minus 1 squared times x cubed plus 3. And it's exactly the same story, which is justified exactly the same way. So this tends to 4, this tends to positive infinity. Again, why positive infinity? Because as x tends to 1 from the left, x minus 1 squared, because of the square, is tending to 0, but it's also greater than 0. And this means that 1 over x minus 1 squared tends to positive infinity. Here, I should add that a nice alternative to all that would have been to start by saying that, start by considering the limit from both sides. So we could have done this from both sides. Like so, and we could have said the same thing. So as x tends to 1, we have x minus 1 squared tends to 0. X minus 1 squared is positive, which means that 1 over x minus 1 squared tends to positive infinity. And this means that this tends to positive infinity. This tends to 4, so the whole thing tends to, the whole limit is positive infinity, with one stroke instead of considering the one-sided limits. Either way, the limit exists and it's positive infinity. Please note that if you had a not power, so if you had 1, 3, 5, 7 instead of 2, the limit wouldn't exist. If you have an even power, 2, 4, 6, and so on, the limit does exist. And that's all. Thanks for watching.